Okay, hello everyone, and thank you all for joining today webinar with the title, as you can see in the screen, Software Containers for Embedded System, really. So while we wait for more people to join, here let me tell you some housekeeping notes. At the end of the session, we will have a Q&A, so if you have questions during the webinar, feel free to try to type them into the chat box. We will address them to the end. If you encounter any technical issues such as audio problems or whatever else, feel free to try, to just use the chat to let us know, and we will assist you as soon as possible. And lastly, I want to inform you that the webinar is being recorded, so will be available on demand on YouTube in about a week. And I think with that, we can get started. So my name is Stefano Viola, and I am the Software Group Engineering Manager and Software Architect here at Toradex. Joining me today are Ron Birkett, Software Product Manager, Open Source and Security at Texas Instruments, and Leonardo Held, a software developer at Toradex, who works with me in the Toradex software group. And both Ron and Leon will join us later during the webinar, because I will start with the initial content that they will join later. Ron in particular will present a more hardware specific part covering the Texas Instrument portfolio and the specific hardware feature, let's say. And then in the end, Leon prepared a very nice hands-on session live. I want to highlight that will be live, where we will show what means develop an application using a container. And with that, let's start. As you can see here in the screen, this is what we will cover today. As I said, I will start with an introduction, a very quick introduction about Torizon and what we do in Toradex. Then I will move to the history of container, just to provide you an idea where this technological, feature come from. What was, the evolution of this feature. And then I will pass just the word to Ron, that will show the TI portfolio and see how you can reuse all the amazing hardware feature available in their product line. Then I will be back and I will deep dive a bit more in the Linux container to see what it means, discovering even a bit if they are impacting the performance side, and then we will prepare ourselves, let's say, to the live demo that I will run together with Leon. Last but not least, that will be the Q&A session, as I mentioned, where we will be all together, try to answer the question that, as I said, you can type in the chat. So, okay. One last note that I want to add: during the webinar, we will do some polls, so be ready eventually to answer some very nice questions. So let's get started. So let me quickly start to explain what we do here in Toradex. So probably most of you guys already know us, but let me just summarize a bit what we do. We are really passionate about making a embedding system simple and accessible, especially on the software side. Our mission is really to deliver a modern, streamlined platform for developing, deploying, and managing IoT embedded Linux system. Torizon addresses most of the common challenge in the embedded software development. For example, simplified development. We produce pre-built production-ready OS images and containerized workflow let you, let's say, go from the prototype to production faster with less complexity. And today we will see how this will, really meet this. Then we also offer a robust, let's say, IoT platform with some very interesting built-in feature. For example, an over-the-air update system secure remote access that we will show today during the demo, because we will use not only, let's say, we will not only highlight the container feature, but also some of the features of the platform, like the updates and the remote access feature in particular. And also, we provide a very good cloud integration. This means that you don't have to maintain and build an infrastructure from scratch. This what means this lower total cost of ownership. So by reducing the development time, simplifying the long-term maintenance, Torizon helps you to save time, reduce risk, and cut the lifetime cost. So in the end, while Toradex ensure the hardware it's robust and scalable, Torizon really unlock its full potential with open source, hardware agnostic, and flexible software stack. And so with this quick introduction, let's just go through the first poll of the day. You should see on the screen the, let's say, the poll. Where are you in containerization journey? No plan to deploy container at this time, learning in order to deploy containers soon, between, I don't know, 1-3 years. See containers as interesting mid-term technology, so like that you're going to use in a couple of years. Watching to see if they make sense long-term, like that you will use it in, I don't know, 3-5 years. So let's see what you think, guys, about it. So I will leave you some minutes just to allow you to vote here, and then as soon as I see that the results are stable, I will eventually stop the poll. I still see people voting, so let's just wait a few more seconds. Okay, I think we can stop and share the results. Okay, this is pretty good. So most of the people, 36% learning in order to deploy containers soon. That's pretty good. I mean, pretty good. And I hope that I can help, we can help you with this webinar to better understand what means doing, build a product on top of containers, let's say. And then, yeah, I see that there are even other people that will use it more, I mean, in the future, but it's still fine. So let's just move forward. Okay, now let's just talk a bit about the history, where everything started here. So in my opinion, really everything started in 1979. And let me tell you why, Because, the story of container in Linux is really fascinating from my point of view. Probably I am too nerd to be, to really judge this kind of things, but I really think that this is really an interesting story that spans decades, and evolve basically from, let's say, basic process isolation that was the initial part, evolving in the sophisticated ecosystem that we have today. The important things to remind is that it's built around some very important and specific Linux kernel feature. So container is a Linux stuff. So it's something that really comes from the Linux kernel. But let's walk together through the most important milestone here that I tried, to collect in these slides. So in my opinion, the early seeds, as I said, was really in the 1970s. So chroot, probably most of you, probably the old guy in the audience, know what I'm talking about. chroot is a system call that, started in the Unix v7. It allowed changing the root directory for a process and its children, effectively isolating the file system view. But, it was really rudimental way, to start calling this container. But I think it's really something that we can identify as where everything started. I really remember when I discovered this feature that I was starting exploring things. I remember I was still at university. But then what happened? Meanwhile, in the more or less in the 2000, even FreeBSD with a feature called jails, what they did was build on top of chroot something a bit more robust, like an isolation a bit more robust, including a way to separate, for example, network addresses, file system trees. And this was going really in the direction of what are the containers today. But again, here we are talking about isolation, so there is no virtualization. There is nothing. It was always used in both cases still the same Linux kernel. And then we are coming in the moment where I think there are the two more. The most important milestone from my point of view. What really make containers what are today, basically. So I think that namespace and just right after control group are the most important feature of the current container infrastructure. But let's see what they are. So Linux namespace was something implemented in the was about 2002. And when was introduced, the version of kernel that was introduced was the version 2.4.19, and the concept of Linux namespace was just try to isolate processes, network, mount points. So it was more about permission, no? So basically, the idea was to isolate user and group IDs, allowing, for example, a specific process to have root privilege, but in the context of their namespace. So this means having root privilege in their namespace, but not in the host system. This feature was finalized then really way later. We are talking about in 2013 with the kernel 3.8, when they kind of let's say we can say that they completed the history, the story, let's say, about the core isolation feature. But then just right after, it's extremely important to mention the cgroup feature. That is another very important feature present in the Linux kernel. This time, this feature was implemented by some engineer from Google. At the beginning, was even not called the control group, but was called the process container. They just changed the name, and they just renamed it later in the late 2007, and was merged. The first version was merged in the kernel 2.6.24. We are talking about January 2008, really kind of a lot of years ago. And cgroup, what cgroup does? So cgroup do a very important things, because while namespace provide a way to restrict, let's say, the access and permission of a process, cgroups provide you something to manage the resources. So with cgroup, you were able to eventually limiting CPU, memory, IO, network of a group of processes. So this was, let's say, a key feature for the containers. Then what was the next kind of natural step? Because what we are talking here, guys, are just a feature available in the Linux kernel. So imagine a sort of API available to be used eventually for this purpose, but there was nothing really available to all of an easy to use of those features. And this step was made, in my opinion, by LXC, the Linux container. This was the first, rudimental, in my opinion, implementation of a Linux container manager. It was providing some very basic tool to create and manage isolated Linux environment. Basically, it was a tool built around these two features, namespace and cgroups. But then I think what was really the game changer, let's say, was really in the 2013 when appeared Docker. And actually, Docker initially was a project of a company, was even closed source. I think the company was called .cloud. It was even closed source. Then they decided to just open really right after. Was about, I think was around March 2013. And while LXC, the Linux container infrastructure, was providing a very, raw containerization, Docker brought a new level of simplicity, portability, and user friendliness, let's say, by introducing the concept of images. They introduced, for example, a very simplified CLI command line tool to deal with build, run, and manage containers. And last but not least, they created the concept of registry that then we will see even in the demo with Leon what actually means practically. Registry is basically something that facilitates the sharing of container images. No? And the fun fact is that initially Docker was using behind the scene LXC. So it was just a wrapper, let's say like that, of LXC. It's just after 1 year that they decided really to write their own, let's say, component to deal with the namespace control group that now it's known as RunC. And I think that's it. Then we come in the modern area where there is even now, let's say, the needs of orchestrate multiple container. And I put it here in the timeline Kubernetes that I think it's really important to mention for containers, even if I think it's not really something that you can relate to embedded system, because to orchestrate embedded system, for example, even as on Torizon, we use Docker Compose that is something way more simple and suitable, in my opinion, for embedded system. And last but not least, in the timeline, I want to really mention something about the standardization, because at the beginning there was just Docker, but now there are many container engine able to provide more or less the same functionality. So was required create a kind of standardization among how to generate the image and stuff like that. And this is the 2015 that I'm pointing out. It's about the OCA initiative. OCA is an acronym for Open Open Container Initiative, basically. And with that, I completed, let's say, the history part of container. I'm calling back Ron that will continue with the, let's say, the more hardware part here. So,
thank
Ron,
you, Stefano.
the audience, yeah, it's yours.
Yeah, I really enjoyed that overview. It's really exciting. And it's neat to see how containers are so tied into Linux. And that's really how a lot of the performance that containers can gain on Linux is achieved. It's not something that's it was baked on top, a couple months ago. It's been there really since the beginning. That's really neat to see. So I appreciate that history. Yeah, so, you're going to need something to run your containers on. So TI makes devices that are a really good fit for that. So I'm really excited to see Leon's demo. So I want to get to that. So let's just spend a real quick minute here talking about some devices that might be good fits for your application that you might want to consider for containers. So let's go ahead and go to the next slide. Yeah, so TI's got a portfolio. We call it our AM6X line of products. These are microprocessors that can run Linux and they can run containers. And we build them with the embedded systems in mind. They're designed for low power, and that also gives you obviously better thermal management and different things like that oftentimes embedded systems need. They are meant to be affordable, so these are not large computer chips that are going to cost a lot of money. These are devices that scale down to a pretty low cost. And what we're really trying to enable is that people that see some of these cool technologies that Linux has at its fingertips, like containers, but they're running MCUs today, and they said, well, I don't get containers with MCUs. They want to transition to that. So at the higher end of that MCU or microcontroller portfolio, there's an opportunity with a low-end microprocessor that can run Linux. And though the devices or the overall BOM cost might go up a little bit as you switch to Linux, the software scalability that you're going to get and the capabilities you get with things like containers that Linux enables might save you a lot of money in the long run. So it's a really interesting cost analysis to look at, as of whether switching over to Linux for all the technologies that it provides and how it makes your software simpler would be a good advantage for you. And we pair that with lower cost devices to make that possible. And then of course we want to be able to scale. You've got many problems that you're trying to solve. We want to provide SoCs or processors that will meet those needs. So we give a wide variety. We also sell them for a long time so that you can start on one project and make that your launch pad for switching over to Linux and trying out containers. And then you can leverage that capability and that learning and go on and do a variety of other projects, choosing the right processor for the right problem, and then knowing that you're going to be able to use those processors for a very long time. So that's really the overall portfolio of capabilities as far as at the lineup level. And we can look at some more advantages that this has with the next slide. We're going to pair this awesome compute capability, the ability to run Linux and containers, with a variety of other hardware that makes solving your problems easier. So we start off with our first line there, which is our general purpose products. This is just a really good compute platform that can run Linux. Most of the time it has multimedia capabilities as well. So if you want to do an HMI or a graphical display to allow your customers to interact with your product, you can certainly do that. But then we can add on other capabilities to that compute and HMI capability as well. One that's obvious today is analytics. Everybody wants to use analytics, and it really has some really powerful options. So adding on an analytics coprocessor or that capability. Audio and DSP are always paramount in the embedded space as well. So we enable a digital signal processing capability if you want to do something specialized like that. Networking is always there with things like TSN, or maybe even industrial networking like an EtherCAT or something like that, as far as being able to want to do an industrial protocol. And then lastly, of course, you might want to do some real-time control. Now, you're probably not spinning a motor from within a container inside of Linux, but you could be using Linux and containers for your communication and the rest of your application. And we have devices that have real-time cores, usually Cortex R5 cores, that you can run RTOS applications on, and they can certainly spin your motors, do your motion control, and do other things like that. So really a nice solid compute platform that runs Linux, and you can add on these other capabilities to meet whatever challenges is happening with you today. And of course, we pair that with great software like our SDKs or the Torizon platform that Torizon offers as well. So let's look at the next slide. Here are some devices that you might want to consider. I won't go into details each one of these. Like I said, I'm excited to see the demo as well. I just wanted to make sure that if you found a particular intersection of these technologies interesting, that you would know what device to go look up more information for. For example, if you're really looking for something small and low cost that can run Linux and just get you started, maybe you're switching over from MCUs, you're considering that, the AM62L product, which is over here on the far left-hand side, is a great device to choose. The AM62 product right above that allows you to scale from 1 to 4 Cortex A53s and add in a real-time core as well with that. So that's got a lot of great capability. Really good networking device if you just want to do standard Linux networking, which is very popular. If you need to go higher in than that, there's the AM62P, which adds more graphics capability for more rich GUI experiences. If you slide over from the general purpose, you can move into signal processing, where we provide devices that provide analytics accelerators as well as digital signal processors as well. So there's a variety of products that are there listed. The AM62A is really interesting if you want to do some lighter analytics and able to run Linux with that. AM62A is a great choice, and you've got a nice scalability up to the AM67A, which is above that, which gives you even more analytics capability. And then the last one is the networking that we mentioned. We've got devices that pair Linux cores with real-time cores that can run industrial protocol stacks. so that you can do industrial protocols as well as pair that with Linux if you need to. A variety of interesting applications like gateways there that you might want to consider, and those are listed under the networking slide there. So AM62 is the one that if you just wanted to say, hey, I just want to get started with one of these, try this stuff out that I saw today, I would recommend looking at the AM62. Toradex has a SOM for AM62, so that'd be a great place to start, and that would be a really good general purpose place to start out with on your journey. If we look at the next slide, we can see that not only do you obviously want to buy or get access to silicon, but you're going to need some other stuff as well. So you want a nice portfolio of devices to choose from, but you also need tools and software. TI provides that in a variety of formats as well. And the reason we're here today is really our robust ecosystem of partners, great partners like Toradex and Torizon that you can leverage to extend the capabilities of these devices and even add on neat and new interesting options like Torizon. And if we go to the next slide, we can see Torizon on top of all these devices and what that really buys you flexibility for. So here's Torizon, which is really a great platform for doing software development. We're going to see that in the demo, and that's the reason I'm trying to get us to that. And that platform now runs on a variety of different hardware platforms. So if you bought a TI AM62 starter kit, one of our evaluation modules, you could try Torizon out on that. And by the way, you could do all the container stuff that we're doing today. If you wanted to play with a community board like the Beagle Play, you could try that as well. If you wanted to start off with a SOM from Toradex, they have a SOM plus carrier board that you could use. And then if you say, you know, I'm actually going to design my own board, you can run Torizon on your own board as well. So all the hardware options are open to you for this great software platform, and you're going to see the advantages of this software platform in the upcoming slides in the demo. So I'd say we just move on over to that, Stefano. I appreciate the time and hope this was useful.
Yeah, Ron, 100%. So thank you so much for the overview.
Yeah, I think we're going to do another poll question.
Yeah, I think we have a poll. Yes.
Excellent.
Yes.
Yeah, so we love the audience participation. So we're hoping you'll help us out with this question. What type of application are you looking to deploy containers to? And your first choice is GUI or HMI. The next one is just data processing. Third one is web. And then a catch-all, other. We didn't get it right with the other three. So you tell us in the chat window what kind of application you're planning on doing. So if you'll help us to fill that out, we'll give a couple of seconds for everybody to get their opinion in. We look forward to seeing the results.
Yeah, I still see people voting. So let's wait a bit.
Sounds good. Which one do you think is going to win, Stefano?
I mean, I always think that probably the graphical UI is one of the that I expect to be high. But let's see how it will go.
I agree. Let's see.
Okay, I think now I see the results are pretty stable. Probably we can publish. Let's see what is the results.
Oh, you were close.
Very close, but still surprising me. So yeah, I think there are a lot of use cases that still need just data processing, no? So and but I mean the second one in line is just graphical UI. So yeah,
that's true.
And you Ron, what do you think? Is this what you were expecting, or?
I'm like you. I thought HMI would be higher, but I guess I'm not too surprised to see data processing there as well. So. It's a good result. So I'd love to hear what kind of data processing you're doing. What kind of application is that? Data processing is pretty broad. So let us know in the chat what kind of stuff you're doing. We'd love to see what you're thinking.
Yeah, super cool. So let's just continue with deep diving a bit in the containers topic, and then we will prepare ourselves for the demo where we'll jump even Leon. So just coming back on my content, so I tried to summarize in one slide before a bit about the history, but how actually containers works. And I think that as you already can imagine, considering the content that I shared in the last slides, Linux container achieve isolation and resource management by leveraging core kernel feature, Linux kernel feature. And I'm talking about the namespace that provided isolation view of the system resources like processes, network, and file system, while C groups provide, let's say, a way to limit the resource allocation of such as, CPU, memory, I/O, and networking. And unlike virtual machine, containers share the host Linux kernel, making them lightweight and efficient for packing application and their dependencies into images. There are no limitations about hardware access. We just a few moments ago, Ron just showed you guys all the hardware features that one architecture like the Texas Instrument one can provide you. And there are really no limit. It's not that in the container you can't use, I don't know, uncertain accelerator, or you can't use a GPU, or you can't use whatever else. You can use whatever is available on the kernel side. So there are really no limitation. So this means that you will be able to run graphical application, and we will see this in the demo because this is one of the stuff that we prepare with zero performance loss, basically. And talking about performance, I want to just highlight here even more that there is really no significant performance drop. And I want a bit connect this with what I read a bit around, because I think around there is a bit of confusion on this topic, because probably people consider or evaluate the containers running on Windows or on macOS. So as I said before, and as I showed you in the history, containers is a Linux kernel technology that reuse the same kernel when they are on Linux, of course. But on Windows and on macOS, this is completely different, because since it's a feature of Linux kernel to be able to use container on Windows or on macOS, on your Windows PC or on your macOS PC, just what happened is that there is a virtual machine that just start a Linux kernel. And that's why you can see some performance drop in that case. But in an embedded device, there is really zero performance drop. The only cons that you could see in an embedded device is about the boot time, because of course, to launch a container, you need to have the container engine already up and running before to start. So if you have a use case where you need eventually to run something after 1 second that you plug the power, this is something that you can achieve only with a customized kernel, customized OS. And this is something that we can even do with our, let's say, Torizon OS. We have some flavor of the OS that are pretty good to achieve those use cases. But why containers? I mean, what is the end? Okay, it's all cool, I can run whatever, but what are the reasons? There are really, in my opinion, there are really several reasons, and this are really depending even about, what is the final use case. In my opinion, there are a couple of that I want to really highlight. The first one is really the efficiency. I think that in 2024, developing an application on an embedded system using container is the most efficient way to do that. Because the other way will be developing the application, for example, in Yocto. This means dealing with recipe, dealing with a complex build system that can, where you can generate some unwanted, behavior or error. Because what means this? It means that every time that you have to modify even an icon, considering the graphical application, when you have to modify an icon, if you don't have a system like containers, you need to rebuild from scratch the full operating system with the new icon, and then eventually deliver the new OS to your devices. Instead, with the container, you can completely decoupling this. Application become a completely separated component that you can manage completely differently. You can develop in a completely different environment. You can deploy by using, a separated artifact. It's everything decoupled. So this reduces a lot the risk of, generating a wanted behavior on the basic operating system. That is the one that allows you to boot the machine. But also, in my opinion, here I'm connecting to the last point that there is in this short list here, simplify the achievement of security and regulation, is because, as I showed you, with container, you have the possibility to decide which permission you want to provide to your application. So, for example, if your container doesn't use at all the network, for example, just deal with the root file system, you don't need to provide any network access. This means that whatever vulnerability that you could have on one component of your application that is related to the network will not affect your application. The same for all other stuff that you can use in an application, because with container, you can really define which part of the hardware the container can access. For example, if you need only the CAN bus, you can just share with the container the access to the CAN bus and not with the I2C or whatever other stuff. So I think this is really, really powerful to really simplify the achievement of security regulation in general. I put a CRA because now it's kind of a hot topic, but there are really way more, let's say, security regulation. One last thing that I want to highlight, it's even way easier, the development and the debugging, because you are able to run the application even on your PC. Of course, it depends. If you are using some specific bus available only on your device, of course, you don't have on your PC. You have to play a bit, by mocking the interface. But it's really easy. Run and debug the application first on your PC and then deploy the same to your device. So it's a slightly different approach than a typical, let's say, development workflow of a traditional old embedded system, let's say. But we will see this in detail in the demo, because Leon will really show what means developing an application with containers. And here, just, right before our demo, I want to just show you, this is a slide that I usually show almost always in my webinar, because it's really show the full ecosystem around the Torizon. And as you can see, it's not just an open source operating system, but it's a complete suite designed to simplify the development, deployment, and management of embedded Linux devices. And on the left side, yeah, you can see, you can notice, let's say, the developer persona that represent anyone working on the application, or, for example, can be even a system integrator, and so on. So Torizon integrates seamlessly with tools like Visual Studio Code, where, for example, we develop internally an extension that help you to simplify the whole container and application development workflow, and allow you to easily use a popular framework like Qt, LVGL, Codesys. Probably those are frameworks that you already know, and also other. In this way, the developer will focus on the functionality without worrying too much about the low-level Linux complexity and security. On the right side, I mean, you can see the device in deployment, and doesn't matter if it's, I don't know, a tractor or, I don't know, a vending machine or whatever. Torizon is able to eventually monitoring, deploy updates, and in general manage your device remotely. And in the demo, we will even show these things. So just be patient. The last slide before the demo. So, but what I can do with container, I think that this moment, if I did a nice job, I think you should already know that basically you can build your own application using the framework, distro, and programming language you prefer. There are really no limits. For example, if you deploy it, if you have today a version of Torizon on field, and you decide to add an additional component, and this additional component is based on Python, but you don't have a Python interpreter. So you don't have to recreate a Yocto build with the Python interpreter, generate a super big updates about the OS. No, you don't need that. You just need to create a container. And actually, you even don't start from scratch, because we provide for you what we call templates, are basically hello worlds with different technology. Here, I just placed a few. As you can see, there is the Python one, where you already have the container ready. So you already have an hello world ready to use that you can just deploy on your machine. And will be, you know, completely decoupled from the operating system. You can update more frequently. You know, without be really worried about that you are going to eventually generate issue on the operating system side. Saying that, let's do the last poll, and then we will start the demo. Okay, what problem are you looking for containers to solve? Application updates in field, better dependency management, simplify CI/CD flow for building software, a mix of all the above. Let's see, what do you think about this? I will leave you some seconds to vote here. I already see some interesting result popping up. Let's see, a few more seconds. Oh, let's see, I still see some people voting, but I think, yeah, okay, now I think it's pretty stable. I think we can close the poll and show the results. Let's see what we have. Okay, I'm pretty happy that you are eventually looking for all the one above, but yeah, but I think it's really interesting to see that you are looking for something eventually to help you to the application updates on field, because this is something that I hope we can really help you to eventually better understand and also inspire you. So, okay, let's move forward. Let's jump to the most probably exciting part of the webinar. So we will show, as you can see in the slide, modern embedded Linux application development using containers. And with me, there is Leon here.
Hello.
So Leon, I mean, yeah, you are already sharing the screen. So
yes. Okay, so this is going to be a demo, and I'll try to show a update, so modifying an application and issuing an update using CI/CD and very modern techniques. We also will try to show the power of containers, how easy it is to use them, how easy it is to deploy applications, and maybe use applications, developed applications in a regular computer, and then deploy these applications to an embedded device. So first off, Stefano, can you please teach us, what am I looking at? Why this clock here says 15 minutes to 6 p.m. and mine says it's 2 o'clock?
Yeah, I mean, right? Actually, yeah. Let's try to explain a bit. So we decided to have a very challenging setup here. So I am based in Italy. So and we will work on the fleet that is behind me. I don't know if you can see here. Sorry for the microphone, but behind me probably you can see a lot of cables and some electronic stuff. Basically, this is my personal fleet that I use for experiments. I have a bunch of devices of many type. And the idea is that Leon, that is based in Brazil, will actually modify the application that you see right now in the screen and deploy my fleet. And let me highlight how he is able to see this application in Brazil. Because what I did was attach to one of the board of my fleet an HDMI input device, really a basic HDMI input device. And through our remote access feature, Leon is able to access this device and able to see the stream. He's just created the connection for demo purpose. He already created. But what you are seeing is really the HDMI input coming from a board in Italy, in Brazil. This is a nice way that you could use eventually to, I don't know, debug. We just did it because it's fun. So,
and of course,
probably.
This is the webinar with TI. So this demo that you're seeing right now is running on a AM62 from Toradex, but it might as well be the starter kit from TI as well. So if we go to the Torizon cloud, we can see this verting AM62, and this is the actual board provision in Torizon cloud that is running this application, right? So what is this application exactly? So as Stefano told you before, Torizon is a minimal operating system, and then we run the containers on top. The way we actually run the containers on top is by specifying a Docker Compose file. So we can have a basic orchestration of many containers going up at the same time, right? So if we take a look here at the packages installed on this verting, we have a base OS, which is Torizon. It's the Torizon Docker release. So this is the latest release of Torizon, the quarterly release. And then on the application side, we have a type of application is Docker Compose. And then the name of the package is TI Toradex Qt Spinny. That's the name I gave to my little spinning cube that I programmed yesterday. So you can see here that this is the version 0.0.2. And we are going to pray to the demo gods and try to update to 0.0.3, right? I created a small repository that contains this application. So from the get-go, a world of difference compared to the Octo approach, because you would have to maintain a bunch of layers and a bunch of repositories with Yocto. With this approach, you only have one repository. It's pretty nice. And we can use CI/CD with very standard tooling from GitHub, GitLab, or Bitbucket, for example. So the Docker Compose that generates this package can be found here. So it's a YAML file description that basically says, hey, please bring up a Weston container that is maintained by us. So it comes from the Torizon namespace on Docker Hub. So it pulls the container from something we call a registry. And then we have our application, right? Our application is a Qt application that runs on top of Wayland. But the image for the application is not coming from the Docker Hub registry. It's coming from the GitHub registry, which is this repository itself, right? So if we come here and take a look at the packages, we'll see that we have 3 images, right? These are Docker container Docker images that are pulled to the device when it instantiates the Docker Compose file. So we see 0.0.1, 0.0.2, and the latest version. And now we're going to create the 0.0.3. So if you go to the actions, so this is the CI/CD approach, right, that you can use to deploy applications to Torizon Cloud and build applications as well. We see that we have a build, and this build, it does everything that you need. So it essentially logs into the GitHub registry container, and then it builds and pushes the artifacts, the container image itself. So my objective here is to change this image, right? If we take a look at the application itself, this application is very standard Qt application. And to show the power of containers even further, I want to build this application locally, right? So what I did was I wrote a small script. I'm using a Mac with Homebrew as the package manager. So I simply install Qt6 on my PC. I'm developing on my computer right now. And I run cmake and then make to build this application. So I can do something like this. And it's going to build. And then I can instantiate it. Whoops, it's gonna appear here. Okay, so this is the same application as it's running on the Toradex board in Italy, but this one is an instance on my computer, no containers whatsoever. Now let's say we have an application that we want to deploy in an embedded setting. How easy could it be, right? This application has a very nice feature, which is we can change the JPEG that wraps around the cube. Very simple feature, but it highlights very well what we're trying to achieve. So there is a variable inside one of my files here. It's called kubewidget.cpp. We could open with Visual Studio Code, for example. Let me bring this over here. So if we scroll all the way to the bottom, I made it in such a way that if this variable is 1, it's going to show the Toradex logo, right? And if this variable is 0, it's going to show the Texas Instruments logo. So now we're going to try to emulate how to deploy the container effectively to an embedded device. So I'm going to change this, right? And then on my machine, so no containers yet. This is an optional step, but it's pretty nice to be able to develop the applications outside of the embedded context. Let's try to build. It had no cache for this specific build, so we built everything again. If we run the spinny cube, it shows the Texas Instruments logo. Now we want to deploy this application to the embedded device, right? How do we actually do this? First off, we must build a container. And to build a container, we use a descriptive language which composes a Docker file. So if we take a look at this Docker file, we have 2 stages on this Docker file, right? The first stage is a build stage. So this container is going to include all the dev dependencies. But for the container that we actually deploy, we don't want any development dependencies. We only want runtime dependencies. So we install build essential from Debian. So again, let's take a step back and think about the Octo way, right? You have to set up, make sure that GCC is properly set up. You have to make sure it's completely working. Here, you can just leverage Debian, so a Debian container, a Debian root file system, and use build essential, right? So this installs a complete toolchain for you. We also need CMake and some packages, the dev packages for developing a Qt application, right? And then we simply copy the source code from the current folder to the build stage. So this essentially means copy every single file that is on the current work directory to my build container, to my container. And then we run builds. And then as the deployment stage, this is a very common pattern for developing applications inside the container. You have a build stage and you have a deployment stage. We simply install the runtime dependency, so what it actually needs during runtime, which makes the container much smaller. And then we copy from the build stage the actual executable and also whatever else we need for that executable to work. In this case, it's JPEGs and PNG files that wrap around the cube, right? So we can already build this. So if we do a git diff, we're going to see that we have some change. I want to commit these changes, right? So I'm going to add them and create a new commit. So this is 0 for the TI logo. So change to show the Texas Instruments logo and save. And now we could possibly already try to build this on Docker Hub, but then we need to understand as well how we create the packages on Torizon Cloud, right? So as I said before, packages are defined by a Docker Compose file, and here we can see that we track this Docker Compose file inside the repository. Especially nice if you want to keep everything under Git, right? And here it's specified that it's pulling the version 0.0.2. But I'm going to create a version 0.0.3 that has this latest change that I did, right? So I'm going to modify this Docker Compose file. So instead of it saying 0.0.2, it's going to try to pull the 0.0.3 build. And save it, diff again, and then I can do something like this. Prepare for version 0.0.3. Great. Now, We can use standard Git things, for example, git stack. We already have a v1 and a v2, so I'm going to create a new version with these 2 commits and push it to Docker Hub.
GitHub. Yeah.
I'm going to push the code. So when I push the code to GitHub, GitHub Actions is going to start building this container for me, right? So, whoops, did I push it correctly? Yes. Oh, I should have pushed the branch as well. Sorry. So git push origin main. So it started building for the new tag. It should probably have 2. So yep. So this is the one. This is the regular for the regular build that I did the branch push, and this is for the tag push. We are more interested in this one. So in the build here, you're going to see some very interesting stuff that I want to highlight. We support Debian. Toradex provides Debian-based containers, right? So if you saw this Docker Compose here, for example, we build our application container and push it to the GitHub registry. But for the Weston container that provides the Wayland session, we actually just pull from Torizon, Weston, AM62, and then our latest tag, right? And if you take a look at the Docker file that generates this container right here, you'll see that our build stage is actually Wayland-based dev AM62.4 as the build environment. And also we use Torizon Qt6 Wayland AM62 as the deployment environment. Especially nice because both of these images, they can make use of something called overlayFS, which essentially means that they are layered, and it's very effective as to save space on the device, to optimize space on the device. So it doesn't mean that if you have 2 containers, for example, in this case here, we have the Weston container and then we have our application container, it's going to be duplicated. The base is going to be the same, so it's really good for size optimization, right? Another thing that I want to highlight here is that you're going to see feeds.toradex.com popping up. This is our third-party package feed we maintain. So if you don't have to, as Stefano said before, right? But Debian is a very nice and stable base, and it's what we recommend and maintain for Torizon specifically. So right now it's building the image and it's going to push the image. It automatically will push the image with the same tag. So this image will be 0.0.3. And it's going to take a while, of course, because when you start a build from scratch like this, it's pretty good to start these release builds from scratch because you make sure that caching is not interfering with anything. But if you want, you can simply also build locally, right? So the commands that GitHub is executing, you can also execute locally and push it somewhere else very easily as well. So now you can see it pushed the manifest, it pushed this new image to our registry. You can see here 0.0.3. And now the only thing that's missing is take this new Docker Compose file that specifies the new tag and create a package with it on Docker Cloud. So remember that I showed you before, we had this package Docker Compose on version 0.0.2. We can come here and add a new package. We support 3 package types. This one is a Docker Compose application type package type. We can attach a new Docker Compose file. So here, just select the compose file. Next, package name. I want the same package name, but this is going to be version 0.0.3. Simply upload the package. Then we can come into the device list, go to our very nice version AM62, initiate an update. Whoops, application update. My package is going to be here, and I really like, it sounds silly, but I really like this feature of the Torizon Cloud that it explicitly states which is the latest package. And then we can start immediately. We can also schedule the updates, of course, and initiate the updates. It was successfully queued. So if we wait a little bit while the application updates over the air directly to Italy, we're going to see the logo change here, right? So
just looking if everything is fine. I mean, it seems that the board is fine. Yeah. I want to just highlight a couple of stuff, Leon, if you allow me, because what you saw now, it's what probably I can define the bare metal container development. And the idea was really to provide you without any filter what really means developing with container. Meanwhile, the application, I think, arrived. Okay, yeah, done. Yeah. And but I mean, everything that you saw here, no, that Leon did, it's really simplified if you use our Visual Studio Code extension, because in the Visual Studio Code extension, you don't need really to write from scratch the Docker Compose file or the Docker file, because the extension will provide you some templates for that. So you already have most of the content. It's just about, you could still tune it eventually you need, but by default, the extension provide for you the file ready to be deployed, provide some hello words that you can just modify and reuse it.
Yeah, and the extension, the templates, they also use the same base containers that I showed you from Debian. So it's two different kinds of application deployment. One is a little bit more abstract than the other, but it's both are very good. But I would say if you're starting out right now, go to the extension. I think it's a very good experience. So if we take a look now at the board that we had and we refresh the page to see everything done, we are going to be able to see that the update was done. It's up to date, and it knows it's up to date because of the versions as well. And here in packages is the version 3. So if you want to try out this right now, you can simply grab the code from this repository, grab an AM62, either the starter kit or the Verdin AM62, and you can try this exact procedure out locally. It's it's super simple.
Perfect. Thank you so much, Leon. Anything else that you think we should show here? I think this is more or less the workflow that we prepared, and I think we can go through the Q&A session.
Yep, sounds great.
Let me call back also Ron here, and let me share the screen. Yeah, I mean, I will share the Q&A page. Okay, so we have a lot of interesting questions. So let's go through it. So let me see a bit. Is there any application for containers in the development of embedded real-time systems? I don't know, Leon, if you want to answer, or yeah, I will leave to you.
So we got to remind ourselves, based on the presentation that Stefano did before, containers are just standard Linux processes, right? They are standard with some more metadata attached to them. So anything you can do with real-time Linux, you are able to do with containers as well. You have to be a little bit more mindful because there are some special configurations that you do for the container to have access to the real-time capabilities. But yeah, there are no issues. It's completely standard and well supported.
Yeah, and I can even share that we have a customer using it, so it's approved, let's say, technology, and you can use by using the Linux kernel with the real-time patches that now actually are not anymore patches. Or, for example, we have some customer that are using Xenomai, that is probably pretty famous on the real-time world. But yeah, you can definitely do it.
Yep.
Let's go ahead. Let's pick another one. Okay. How easy, complicated is to enable specific hardware in the containers? For example, some proprietary IE accelerator. Leon, I will leave even this to you.
Good question. It's somewhat it's not standard, right? So if you're using a downstream kernel, you have to add some packages to Debian, for example, with what we do, to enable certain features from the user space perspective, right? But the good news is that for our boards, Toradex generally takes care of that if you use the Debian containers that we provide. And also over time, the tendency is to upstream most of the things. So any general container should work with specific hardware accelerators. So to summarize, if you're using any Toradex provided container, it should work fairly well with almost all peripherals and hardware accelerators without issues.
Yeah, I mean, if I can add something, guys, it's really simple here, the concept. So if your hypothetically AI accelerator, it's something present in the, it's supported at Linux kernel level, probably he will generate a device under dev, I don't know, dev accelerator or whatever. Could just be that there are some syscall or IOCTL are called not to talk with the external device. You can actually access those calls, those interfaces in the on the container side. There is nothing that prevents you to do it. It's just a matter, of course, to sharing it. You could, by simplicity, and also I encourage you to do this only during tests, you could even open everything. Like, because you can run the container in a way that it's called the privileged, that will share everything. So the container is able to see just the whole kernel, let's say, space. But then the idea is that you select exactly what you need to do. But there is really no restriction, nothing. I mean, you can actually do it. And soon, because, for example, we support in our product portfolio the even the Aquila. I mean, which product is that we have the EI inside? Probably it's even the Beagle Y. I think the Beagle Y. I think the Beagle Y has the AI accelerator on. I'm correct, no? There are some accelerator in the Beagle Y AI.
And the AM69 as well that has the NPU cores, right?
Yeah, we will prepare some container. I think we already have something internally, but we will prepare something for you that will be available in form of template, let's say. Okay, let's go to a next question here.
There's a very interesting question that I see on here. What are the most expensive? What are the most expensive actions between kernel and container? For example, usage of dev devices. For example, serial devices with 1 megabaud RTS, CTS with 80% load. This is, I think it's a really nice question because it essentially is asking, what are the limitations of the performance limitations of using containers? And the answer is very simple. Whatever are the performance limitations of not using containers? So if you have any limitation of the usage of a dev device, for example, on a regular Linux operating system, it's going to be the same on the container. It's just a process, so no difference.
Yeah, if I can add, because I was really reading about this, even some scientific paper, about experiment that people do. I read that, and also I should admit that I did even some experiment on that. The only way where you can get some latency, it's when you create inside the container infrastructure some extra layer about networking. So it seems, because with Docker allow you to create gateways, to create extra network configuration. So in that case, you have some. We are talking about, I don't remember what was the delay for, about some microseconds that you have. But because you are really generated some extra layer, at that level, really you are generating extra layer. are not needed for load use case, because you could just bridge the network and use the exactly same network of the host, have even in the network case zero loss. But on the CPU side, on the memory access side, it's not that this let's say is lower, because the same way that a regular Linux process have to access to the memory, it's the same of the container one, are the same process. There is nothing in the middle. The only stuff that there is not really in the middle. It's something that is in the kernel, as I showed in the presentation, that will just define the permission about the access permission. Let's see if we can do another one. So let's pick this one. Why are you using Docker Compose for container orchestration compared to using alternatives such as Docker Swarm? Leon, I leave to you.
Yeah, so I really like this question. I think there's a spectrum of orchestrators, right? So in one side, we have something that is very simple and straightforward. It's to bring containers up and then do some basic health checks on them. And on the other hand, you have Kubernetes, which is really meant for massive deployments. And in the middle, probably there's Docker Swarm. I would say that Docker Compose is sufficient and pretty good for 99.9% of deployments that you're going to do embedded with containers. But it's completely fine as well if you want to customize, let's say, Torizon OS with Torizon Core Builder and introduce something different like Docker Swarm, as you mentioned. If you have a very specific use case for that, for example, you need zero downtime for something and you want to use a more robust orchestrator capability. But Docker Compose generally covers, I would say, almost all of the use cases.
Yep, thank you. I saw another very interesting question here. So is there any rule of thumb that, about how many containers to run on an embedded system, like one app per container or some sort of grouping the application? I think this is a really interesting question. So there are no limit in the end. The limit are the resources of your device. So if you have a device that you have, I don't know, we have, for example, our Aquila IM69, where you have a 32 gigabyte of RAM and a lot of disk space, you can really run whatever you want, even probably, I don't know, even thousands of containers if you want. It depends what the container does. But I think I understood your question is more even about how to organize the, let's say, the application inside in a typical container scenario. I think this really depends on what is your use case. I could provide you an example when, for example, you have a component that retrieves data from a sensor, and then, for example, you have the needs to save those data, to elaborate and save those data in a local database, and then you have, for example, another part that do some filtering and send the data on the cloud. For example, in this way, I already identified the 3 components that I could eventually use to run in my system, and they could, let's say, be connected each other with a local network, for example, in the containers. Now, this can be an example, but it's really up to you. I think that the rule here should be the same of when you are implementing something on the host system. I don't think there is really something that you should think a bit more about that. So probably divide by objective, by responsibility, by even permission that you need to provide. I don't know, Leon, if you have something to add.
I think it's an architectural decision, right? I can give some nice examples from previous projects. We had a project where we had data processing, a data processing application that ran in one container, and the people who are developing this application, they were really doing some very specialized coding, embedded oriented coding, but we also had a web app running simultaneously. So it was very clear for us that the web app developers, they wouldn't necessarily need to understand what the other data processing application was doing. So the division comes very clearly. Also, in the case of databases, for example, it's very common to see databases being run in one container and the application running in another. And then Stefano mentioned doing the connector via the internal Docker network. So it's more like a architectural decision. I would say do not go overboard with trying to over separate things, but use it as a nice tool for development.
Okay, so I think we can conclude here the webinar. I think it was really, really cool. Thank you so much, Ron and Leon, to be here. Thank you also, you all, the audience. And yeah, guys, see you next time with the next webinar soon. Thank you.
Bye-bye.
Thanks,
Bye-bye.